Welcome, good morning, Fabulous Fives. Lovely to have you with us. Feeling very lonely here in my office, so I just want to give a shout out to some people I know are watching. Some of the girls from grade 5 at St. Cyprian's, where I teach. I normally teach them robotics and coding, but I know that they've been watching. So I know Melissa and Natalie are watching. I just wanted to say hello to them. And I hope that there are many more of you watching. And I do like people to come back and watch again and again. So just wanted to check in to see that you're remembering to do your times table challenge. A reminder, that means you first of all get your timetable right, then you time yourself, practice some more and see if you can get a faster time. So I'd love for you to be able to do each of your timetables in under 20 seconds. You can see whatever as long as you're getting faster through your practice and you're getting it right, that's what really matters. Okay, we have been doing fractions, and today we continue with fractions, having a look at fractions and adding fractions. A reminder that if you have any questions, please email me grade5@worksheetcloud.com, and after the lesson, just to check that you've understood what we've done today, you can click on the link at the top, which has a worksheet that will help you to check whether you've understood what we're doing today. Fractions 4, adding fractions. A recap of what we've done so far with fractions, and then looking at today's lesson goals. So first of all, what we've done with fractions so far is we know what a numerator and denominator are and where they come from. We've looked at equivalent fractions, so different ways of writing the same thing. And we've also ordered fractions, so putting them in order from biggest to smallest or smallest to biggest when the denominators or the numerators were the same, and also putting them in order when we had different denominators, and that we did by using equivalent fractions. So today we're going to look at adding fractions that have the same denominator, and then we're also going to add fractions that have different denominators, and again we'll use equivalents to help us with that. We are going to need to know what we've done with equivalents, so I'm going to go and have a look at last lesson's homework, go through it quickly. Hopefully that'll give you a reminder of what it is that we did with equivalents. Right. Bit small, but let's see what we can manage. So first of all, I was checking whether you could write it in words. So looking at the first one, we can see that there are 2, and when we've got a 3 at the bottom, we call it thirds, so 2/3. The next one, we had 5, comes from our numerator, and we were looking at a 9 at the bottom, so we have 9ths. Next one, 3/8. 3 comes from the numerator, 8ths comes from our denominator, EIGHTHS, from the denominator. We were then looking at this one, where I gave you a pair of fractions, and I asked you to find, first of all, make them equivalent fractions, and then to say which one of them was bigger. So in the equivalent fractions, we're going to write them as equivalents. I notice that with the first one, if I times that by 2, and I must remember to do the same to the top, I can get 4/12, which is now the same as the other one, which I'm just going to rewrite. So now I can compare them. I'm looking for the bigger of the 2. It's the second one, because the denominators are the same, so I can just look at the numerators. So my answer then is 5/12, 5/12. Looking at the next one, I notice that I can do something to a 2 to make it to a 10. I'm going to times it by 5, and what I do to the bottom, I do to the top. Times that one by 5 too. First one remains the same, unchanged. Comes from over here. The next one, this is the one that changed. 1 times 5 is 5. 2 times 5 is 10. Now I can see that they are, in fact, I can see that they both have 10s at the bottom. I can compare them. This one is the bigger one. So your answer can be written as 5 over 10. We can also write it in its original form, which was 1 over 2. So both of those answers is correct, 1 over 2 or 5 over 10. Next up, I gave you a set. I asked you to first make them into equivalent fractions, and once you've done that, to order them from smallest to biggest. So first up, we're going to put them in, make them all the same. So if I look, I've got 3 different kinds of fractions there. I've got tenths, I've got fifths, I've got tenths, that's again the same, fifths, another one of this fifths, another tenth, and I've got 2. So I've got to try and find something that 2, 5, and 10 all go into. So I'm going to do my times tables quickly underneath that, and let's see. 2, 4, 6, 8, 10. Well, I noticed that that's there. Let's check. Right. I have 10 in each of them, so I want to make all of my denominators 10. The first one is already 10. I'm just going to leave him the same. Next one, I need 2 times by 2 to get to tenths, so it changes to 4 over 10. It's an equivalent fraction, but with tenths. Next one stays the same. It's already tenths. This one I'm going to have to times by 2 again. I get to 2 over 10. This one, if I times it by 5, I can get it over 10, and this one's already tenths. It stays the same. Now perhaps it's taking you a little longer than me to see which number I need to change it into, and this is part of the reason why I've been giving you the times table challenge. Is the better your times table, the easier it is you'll see. So I won't need to write down my times tables on the right hand side, because in my mind the 2, 5, and 10 times table are so set, I can already see in my mind that 10 is what I need to make it. And the better your times tables get, the easier it'll be for you to figure out these sorts of things. So it's not without reason that we ask you to do these sorts of things, like learn your times tables. All right. Oh, I've been trying not to say all right, because I know that I say it a lot in my lessons. The question asked us to go from smallest to biggest. Now that our denominators are all the same, I can just look at the numerators. So I see that this one here is my smallest. This one here. By circling them or by crossing them out, I can see that I've already used them, and it makes it easier for me to find what I still have to sort out. So the next one is 4 over 10, 5 over 10, 6 over 10, 9 over 10. All right, so there we go. That's last week's homework. A revision now for us looking at equivalent fractions, which we are going to use during this lesson. We have 2 important rules when it comes to adding fractions. The first rule is that our denominators have to be the same before we add. And the second one is we only add the numerators and the denominator stays the same. And I'll draw a picture for you when we're working so that you can see why that is. Get my notes. The first one I'd like you to have a look at is 1 over 7 plus 3 over 7. Okay, I'm going to put my rules on the right quickly, and just so we can check. Denominators the same. And secondly, don't add denominators. I think actually I'm going to quickly change this number just to make my drawing a little bit easier. I'm going to make that over 5. All right, said it again. So firstly, we need to check that our denominators are the same. They are. And then we don't add the denominators. This is where I'm going to draw you a picture and why I decided to make it 5 instead of 7, because dividing into 7 isn't so easy. So I'm going to draw a shape that has 5 parts. I'm going to draw each of these. All right. Not perfect, but there we go. In the first one, we have 1/5. In the next one, we have 3/5. And if I do a count there quickly, I can see 1/5, 2/5, 3/5, 4/5. 1/5, 2/5, 3/5, and 4/5. All right, and that's why I get 4/5. What I don't suddenly get is this. I don't suddenly get, this is me making tenths, I don't suddenly get 4/10. 1, 2, 3, 4. As you can see over here, this amount and these three together make up most of a circle, more than half, quite easily. And if I look at what I've drawn here, it's much less. And that's why you can see that if I do this, if I add my denominators, I'm making a mistake of making my fraction pieces smaller. So what's happening is I'm looking at fifths. And so in my answer, I'm still going to be looking at fifths. So we don't add the denominators. We only add the numerators. And that you should see is fairly easy. 1 plus 3 is 4. Hope you understand why it is that we don't change the denominators. I'm going to now add in that one that I rubbed out, 1/7 plus 3/7. Not that you're going to find this one very difficult. We know why it is that we don't add the denominators. It stays as 7. 1 plus 3 is 4. We get 4/7. What if you got something like this? Before you even think of doing anything, I want you to check the rules on the side in light blue. First of all, the denominators must be the same. If I have a look at that problem, I can see my denominators are not the same, so I'm not actually allowed to add them yet. So the first thing I need to do is make my denominators the same. I'm going to give you quite a specific layout for how I want you to set these out. And the reason is that I don't want you to make mistakes by doing too much in your head at the same time. So first things first. We need to make our denominators the same. I've noticed, and this again might take practice to do, but because my times tables are there, I can notice that I can do something to this to make it into a 9. And what you do to the bottom, you do to the top. Timesing that one by 3 as well. I now get 3/9. I've used an equivalent fraction to make this one over 9 staying the same. I've not changed this one at all. It's just coming down from there. I've rewritten him over there. I now have two fractions that both have a denominator of 9, and that allows me to add them because my first rule is ticked. Now it works like the ones we did before. We don't add the denominators, we do add the numerators. So 3 plus 2 is 5. And there's your answer. Just like that. I'm now going to give you two that I'd like you to try on your own. I'm going to give you about a minute for each. and then I will go through them. I will leave the example on for you. I'll give you about half a minute for this one because the denominators are already the same. You put my rules on the side again, you guys can get going. Oh, my internet's being a little bit slow. I don't write that slowly. First, we need to make sure the denominator is the same. Well, they are. And secondly, we need to make sure that we don't add the denominators. I'm going to just pause my video for a moment. And we're back now that my internet has managed to catch up. So I was saying we need to make sure the denominators are the same, and we make sure that we don't add the denominators. So in this example, our denominators are already the same. We don't have to change them. 1 plus 2 is 3, and there's our answer. I hope you managed that on your own. If not, don't stress, we'll practice it in our homework today, and hopefully by the end of the homework you will feel a little bit more comfortable with it. Our next one. So you will do this on your own. I'll give you about a minute head start for this one, and then I'll work through it as well. So first up, you're checking the first rule. Are the denominators the same? If they're not, you need to make them the same. Looking back at the question, I hope you managed to notice that if we times this side, the left-hand fraction, by 2, we would get it to be over 10. So this now becomes 4 over 10. We've just used an equivalent fraction to write it a bit differently. On this side, nothing changes. I'm just rewriting it. That's not maths, that's just copying. Now we have our denominators being the same. Now we can add them, making sure we don't add the denominators, so it doesn't become 20, it stays 10. 4 plus 3 is 7. There's our answer. So we've looked at adding fractions when we have the same denominator, and now we've looked at adding fractions when we've got different denominators. Up until now, we've looked at fractions where one of the fractions, or one of the denominators, can be turned into the other one. Coming up, we're going to have a look at ones where we need to do more than that. We need to have a look at 2. Come on. Here we go. This is where we were. So up until now, we've only had to worry about one of our rules. Oh, we've done that. Okay, so this is where we're going to push ourselves by looking at both denominators. So again, I'll do two or three examples like this, and then we'll let you have a go by yourselves, and then I'll work through them, and then you can see what you can manage with the homework. What if we had something like this? Take a moment, see if you can figure out what we could do to make the denominators the same. Can't do anything to the 2. Remember, we can only use times and divide. So I can't do anything to a 2. I can't do anything to the 3. So this time, I'm going to have to ask myself, what can I make both of those into that they can both fit in? Let me say it a little bit differently. What could both 2 and 3 fit into? Now, hopefully you know your 2 and 3 times table well enough that you don't need to write it down, but writing down is a good practice to have, especially when our denominators are a little bit bigger. So on the side, I am quickly going to jot down my 2 times table and my 3 times table. Just the first few. Underneath, I'm going to do my 3. Do you notice anything that is in both? There are more than one. We want to pick the smallest one that's in both. I can see that 6 is in both of those times tables. So what I'm going to do is I'm going to make both of these denominators into 6. So what do I need to times 2 by to get to 6? If you can't think of it in your head, have a look at the times table on the right. This is my 2 times table, so 1, 2, 3. Times by 3, what I do to the bottom, I do to the top. So this fraction now becomes 1 times 3 is 3, 2 times 3 is 6. It's an equivalent fraction over there. Having a look across to the right, I'm going to look at what do I do to the 3 to make it into 6. Well, 1, 2 times 2, do the same to the top. I get 2 over 6. That is an equivalent fraction on that side. Now that my denominators are the same, I can go ahead and add them exactly as I would have. Denominator stays the same. 3 plus 2 is 6. Sorry, 3 plus 2 is 5. There we go. There's our answer. Well done. Let's have a look at another one. If you'd like to, at this stage, on your pencil, with your pencil and paper, see if you can get ahead of me, you are most welcome. If not, you're welcome to stay with me as I go through them a little bit slower. There we go. What if I had 1/4 plus 1/3? What would I do in order to make these the same? I need to find something that 4 and 3 can both go into. If you can't think of it off the top of your head, jot down your times tables. 4, 8, 12, 16, 20, 3, 6. Well, I can stop. I see I've got one that's in both. I need to make these both over 12. What do I times the 4 by to get to 12? 1, 2, 3 times 3. What I do to the bottom, I do to the top. 1 times 3 is 3. 4 times 3 is 12. Having a look at the 3 times table. 4 times that by 4. What I do to the bottom, I do to the top. Just shift down my screen a little bit. 1 times 4 is 4. 3 times 4 is 12. Now that my denominators are the same, I can add them. Stays as 12. 3 plus 4 is 7. There we go. Answer solved. We have time for one more. This is the one that I'm going to let you get ahead with, and then I'll give you about a 40-second head start. We've got time for that. Six plus 1/4. Right, so remembering you need to make the denominators the same before you add them. If you can't think of what it is that you need to make the denominator, write down your times tables on the side. I'll quickly jot down the times tables for you. If you haven't finished it yet, you can go through it at the same time as me just to check that you're right, or as far as you've gone. And if you are finished, let's check if you got it right. I needed to make a 6 into a 12. I put my 12 there so long. 1, 2 times 2. There we go, it's equivalent fraction. 2, 3, so times 3 times 3, 3/12. That's just an equivalent fraction. Now that I have both of them having the same denominator, I can add them. 12 at the bottom, 2 plus 3 is 5. There's my answer. Good. I hope that you've got that. Switch back to a presentation quickly. I hope I've stretched some of you a little bit in this lesson. That does bring us to the end of the lesson. Just a reminder that if you have any questions or anything you'd like me to cover on fractions or on any other topic, please drop me an email, grade5@worksheetcloud.com. I hope you've enjoyed the lesson, or actually more important to me is I hope you've learned what it was we were doing. If you did enjoy the lesson, that's fantastic, but I'm more interested in whether you understood what it was we were doing. Reminder, homework, worksheet, if you click on the link above the page, you can do it. You can either mark the answers with the memo that's there as well, or you can wait until the next lesson when we go through it. I hope you have a fantastic rest of the day. It's been lovely having you with me. Goodbye.